A while back, I made a video showcasing the little voltage limiting diode inside these old style Lego motors. And immediately after I made that video, I put this motor back together, obviously because I had to crack it open to show the diode, and the motor was not okay. Now specifically what was happening was that I was turning the motor and I was putting a great deal of force on the shaft of the motor and it was just barely moving. Now, I mean, at this point the motor works, it's fine, I fixed it. But the fact that it was taking a great deal of force to actually turn is what told me what the problem was. I have here another motor that has never been taken apart, and as you can see, it's totally fine. And here I have a homemade connector that goes out to two female plugs on the end. If I take a jumper wire and short circuit the two ends of the connector, then now if I plug this on the motor, then the motor is short circuited as well. And now when I turn it, it displays the exact same symptoms that the other motor had when it was not working. With this unadulterated motor, I'm able to turn it fairly easily. And it revs up to the same exact speed that you would if you were feeding it 15 volts because of that, well, you can't see it there, but the voltage limiting diode in the back, as soon as it gets to the point where I'm cranking it and it's producing 15 volts, the voltage limiting diode starts to conduct and dumps the energy, and so I can't crank the motor any faster. But now if I attach the shorting block and try to crank it, it's nearly impossible to turn. You can see how much force I'm applying by how much that axle is twisting. But given the symptoms, I knew that the motor itself was not seized, because even the slightest amount of force will cause the motor to turn, albeit slowly. This is exactly what the broken motor is doing. At least it's not doing it right now, because I fixed it. I'm not going to try and artificially induce it now, because this motor works now, but those symptoms told me that there was a small piece of metal that had gotten lodged in the commutator at the back of the motor. The commutator is the little bit with the 6 prongs there that you can see turning around as the brushes touch them. If the bars on the commutator are shorted, then that effectively shorts out one of the coils on the motor, which causes the same drag as you would if you had shorted the entire motor. Now you see how small that commutator is. I wasn't about to just start poking around in there to try and remove a piece of metal that I didn't even see. I was pretty sure I wasn't going to be able to fix it, so I just finished taking the motor apart and was left with this. And then I just wanted to have some fun just blowing up this motor as hard as I could. So I pulled off the brushes assembly and put this motor back in the case and then attached it to my gears here so I could spin it at ridiculous speeds. Now, of course, at the time the motor was seized, so I couldn't start by just spinning it with that gearing because I wouldn't have enough torque, as you saw. So I attached the crank directly to the motor and started pushing it really hard. And then all of a sudden it's loosened up, and I wasn't exactly sure why it did that. But at any rate, I now had enough torque from the gears to be able to turn it with the gears. So I put it on the gearing assembly and started cranking it. And I cranked it up to a ridiculous speed. And while it was spinning, I noticed that the commutator on the back started arcing like crazy. And so I kept cranking it, and cranking it, and cranking it. And then it stopped arcing. And I wasn't exactly sure why it stopped arcing. I figured the thing had finally shorted out and died. So I pulled it off and went to put the motor back together, put the brushes assembly back on, and then I wanted to confirm that it actually was dead. So I stuck a little LED on there, but it wasn't dead. It was still producing plenty of energy. The commutator was working, the brushes were working, the coils were most definitely not shorted, and I was even able to run it by sticking a 9-volt battery onto the back of it. It's a motor, it works. And for a while I was quite at a loss for how my attempts to destroy this motor actually fixed it. But after a lot of thinking, I concluded that the little bit of metal that had gotten stuck in the commutator, when I cranked the motor up to those ridiculous speeds, the high voltages generated by the rotor running at those speeds must have sent enough current through that little bit of metal to destroy it and burn it up. And that's where all the arcing was coming from. When the metal finished burning up, it stopped arcing. So now I know. I have 2 motors that work now, and they're basically in good condition, apart from the fact that I took that one apart. But the motor itself on the inside is totally fine. I suppose the lesson I could learn from all of this is that You might think you're just farting around, you might think you're just having fun, but you'll always end up learning something. And today I learned that these motors just can't be killed.